Hello, everyone, and thank you for joining us today. My name is Sean Sullivan, and I will be your host for this Technology Gateway webinar on NASA Langley's technology Safe2Ditch, an autonomous crash management system for small UAVs. Our presenters today are Trish and Lou Glaab, the inventors of the Safe2Ditch technology. Trish Glaab is a research engineer in the Systems Analysis and Concepts Directorate at NASA Langley Research Center in Hampton, Virginia. She has more than 30 years of experience in human-in-the-loop simulation modeling and in NAS-wide systems-level simulation development and testing. Additionally, she is proficient in several software languages and in software architecture design. Lou Glaab is currently the Assistant Branch Head for the Aeronautic Systems Engineering Branch at NASA Langley. He has been working at NASA Langley for 30 years in the areas of low-speed aerodynamics, stability and control, crew systems, synthetic vision system displays, entry, descent, and landing technology, and unmanned aerial systems. Now, following Trish and Lou's presentation, we'll hear a short talk from Jennifer Viudez, a licensing specialist at Langley Research Center. She will be speaking on how NASA Langley partners with outside organizations through technology licensing. Okay, a couple things before we get started. I'd like to point out that your microphones will be muted throughout this presentation. So if you have questions, please type them into the chat box and we will get to them during the Q&A session at the end. At this point, I'm going to turn it over to you, Trish.
Okay, thank you very much, Sean. And I'm not going to waste any time. I know our time is limited here. So without further ado, I want to give a little bit of background for those who aren't quite as familiar with the technology. Then I'll talk a little bit about how the components fit together, and then finally how we envision the licensing opportunity and what we're hoping for in commercial partners for this technology. So first off, Safe2Ditch, what exactly is it? As Sean said, this is an autonomous crash management system for small UAVs, and I think I might have coined the phrase crash management system, but that very succinctly says what this system does. On our prototype, it currently resides in the software on the onboard computer. So in the lower left or the lower right portion of the screen, you see our prototype. That's a Y6 vehicle. And then the arrow is pointing to the onboard flight computer, and that's actually where all of our prototype software resides right now. But in the final form, we envision this either to be something like an independent avionics component that would plug into the system, maybe through the autopilot, or even potentially to be a new safety mode within the autopilot itself. This system basically performs the same steps that a pilot would take in a manned vehicle, like a GA aircraft, if suddenly he was faced with a situation where he had to make an emergency off-field landing. So the only mission that this system has is to make sure this vehicle is safe to ditch. It doesn't do collision avoidance. It doesn't do pre-flight reliability. It specifically is invoked and engaged when the vehicle is imminently perceived to be in a crash situation to manage that crash safely to the ground, as safely as possible. So from a very high level, this is generally how it works. I know there's a lot of confusion with previous questions we've gotten in the past. People don't know where Safe2Ditch software begins and ends and where the rest of the vehicle comes into play. Safe2Ditch is actually an intelligent set of autonomy algorithms, and it uses the components that already exist on these vehicles. And primarily, we're designing this to be something very suitable for something like your typical small UAV camera drones. And so Safe2Ditch isn't going to replicate autopilot functionality. It's going to use the autopilot that's already on the vehicle. And it's not going to come with its own camera and replicate camera functionality. It's going to speak to the camera and to motion recognition software that's staged on the vehicle if there is a camera. If there's an infrared camera, likewise, it'll talk to those systems. If there's supplemental hardware, maybe there's a siren for a warning bell that people could alert folks in the area, or if there's a parachute, it would talk to these systems, but itself, it is just a software package that takes all of these components and ties them into something that does this autonomous set of algorithms. And that's how it can be so lightweight, because it doesn't have to come with the hardware. So I want to talk about a notional scenario, just so everyone further understands what we're talking about here. And this is one of the original scenarios that we pitched when we were trying to get our initial package of funding back in 2015. So in this notional scenario that's kind of cartoonified in the lower right, we have a small UAS that's en route to a mission and something goes awry. So the something going awry might be unexpected sudden battery drain. Maybe this is a fuel burning vehicle and there's suddenly its fuel is run out. It got some kind of a fuel leak. This could even be a weather anomaly, so suddenly it's hitting significantly stronger headwinds than were predicted. For whatever reason, the vehicle Safe2Ditch system perceives that it can no longer reach its intended destination, nor can it get back to its home base. And so the Safe2Ditch system detects this anomaly and engages. It self-engages. It doesn't need a pilot or any kind of a ground system to tell it when to engage. And it starts evaluating its crash site options. So in this notional scenario, the closest possible ditch location is actually a high-risk area. It's a schoolyard. And so through the database interaction, it realizes that for this day of the week or this time of the day, that this is not a very good option. It has a little bit of life left in it. It looks into the next possible ditch location. In this case, it's a parking lot. It might be clear. There's some risk to that. It's a better option than the high-risk location. But however, here there's a third option that's a very low-risk area, a swamp, and so the triaging mechanism inside Safe2Ditch is going to say, I can make that low-risk area, and so that's what I'm going to target as my ditch site. It lays in a route to that site and immediately starts inspecting, just in case there's unexpected occupancy in that site that it's selected. And the whole way down, as it's crashing onto that site, as gently as possible within the current vehicle's potentially disabled capabilities, it's inspecting just to see if it needs to tactically maneuver at the end. So that's generally the way a notional scenario might go. I want to talk a little bit about what motivated us to create this system in the first place, because really the original intent was to try and go out and just get someone else's system that did it, and we really couldn't find any other system. So that's what started us down this Safe2Ditch path. We really wanted to create pilot-like decision-making through autonomous avionics. And the impetus for this was that we know, coming into the scene, these small UAVs with very limited carrying capacity and sometimes a different caliber of system and a different maturity level, that these vehicles were probably not going to be able to meet the FAA's reliability requirements that you see for manned aircraft like general aviation or for commercial transports. And so if these vehicles were ever going to have a chance to meet some of these bigger visions for the technology, we needed to find a way to possibly mitigate the safety risks and make a case to the FAA that there could be a safety case even though the reliability of the components was not necessarily going to be able to handle it to the degree that they need it, and there wouldn't be a pilot on board. We designed it to function not only for some high-end commercial components, but we wanted it to also work with hobby-grade components because we saw this as a very large part of our customer base and potentially a large source of where some of these mishaps might happen. So as we were designing it with the commercial operators for fleet operations or beyond visual line of sight, we always kept in the back of our mind that we want hobbyists to have a low enough cost point for this particular piece of avionics if they could buy it, so that they would think in their minds, I just can't afford not to use this thing. It's going to potentially save me a lot of heartache and maybe some injury to someone down the road. So we always hoped that our price point, once we got to a commercialization stage, could meet the types of costs that these hobbyist consumers were expecting from other components on their vehicles. And so for us, that was about the $300 range or cheaper. Otherwise, if we got beyond that, we were afraid we would lose some of the market. So that's where if you've seen the 300 or below cost point, that was where that came from. That was just our notion of what this needed to come in at to get the biggest market share. So why is a technology like this needed? Well, for manned aircraft, the pilot is really handling the emergencies for off-field landings, and this happens not all that infrequently for things like GA aircraft. And they can handle it very flexibly. So if something goes wrong and the GA pilot is flying and he realizes that he can't make his airport anymore, he can immediately start thinking, what are my options for my own best survival and to protect others on the ground? And of the options that I have, which one offers me the best success to actually get to it? How do I adapt my flying to get there, if I need to at all? Maybe my vehicle is disabled and there's something I need to do to compensate for that. And as I close in on that site and I see the site better, if I realize that there's something unexpected there and now I can't choose another site because my vehicle can't get that far, what am I going to do tactically to give myself the best chance of survival and of not causing injury? For small drones under Part 107, which is the FAA's commercial license now available for people to start making money on these small drones, the pilot is really still expected to handle these types of emergencies. And this is built right into the Part 107 restrictions. So unless they have a waiver from the FAA for otherwise, the pilot has to have his vehicle in his line of sight at all times. He can only fly one vehicle at a time. And Part 107 also says there's no overflight of people who aren't directly involved in the flight operations. And so right here you see there's a lot of restrictions that go with this one pilot, one vehicle paradigm. And specifically, they really don't allow what we see as the big vision for these small UAS, for the types of things that you hear as the billion-dollar markets. And these pictures that you're seeing now are really what we're thinking of as the big vision. These are the things that these small UAS can potentially do that we couldn't have done in some way without them. Maybe fire spotting, where you're sending your drones into places that your humans would be put at risk to do, or package delivery, search and rescue operations, maybe law enforcement operations, and I believe that's a picture of a hornless rhino down there. And they're already using small drones to try and do poaching enforcement down in some parts of Africa. But you can imagine that if you're doing package delivery and you're at your distribution center and your distribution center wants to send 30 packages out, it's really not a very realistic and commercially viable option to have 30 pilots sitting on the roof of that distribution center and only being able to deliver packages as far as their own eyes can see. So to break out of that one pilot, one vehicle line of sight paradigm, you really need to put this pilot-like decision-making and this potential safety mitigation on board each vehicle independently to act as to do that pilot function for safety in case of an emergency. The market for these is potentially excellent, and these numbers that I'm showing on the screen now are lifted from the FAA's 2016 Small UAS Forecast Report. So last year, the FAA did a bunch of research, and they combined data that they had from their Part 107 from pilots who were actually applying for licenses. They went out and they canvassed some of the companies that were selling the vehicles and tried to map trends with avionics and licensing and other market factors. And they came up with this prediction that by the year 2021, there would be between 3 and 6 million small UAS sales per year in the United States. So that's a pretty high number alone, but when you consider that this was keeping in mind their Part 107 limitations, so potentially this is even a this is a conservative number, because if you can provide a way to break out of that one pilot, one vehicle paradigm line of sight, it could even be higher in my mind anyway. That's my own opinion. So the money-making potential is really high, and also the potential for mishaps is high. So we definitely need some kind of a system like this, and our hope is that this would be an incentive for someone who takes on the technology to try and commercialize it, to get them over that inertia hurdle that's going to be the realization that any company is really, there's probably going to be some upfront investment just to stage this in a way that the average consumer could actually buy. And that leads me to what our NASA vision for commercialized Safe2Ditch looks like. So when we're developing this, we put it in an onboard flight computer, and we write our software. All of our software right now is in Python. and we load it on, do all the maintenance on the flight computer to get the libraries that we need. But we know that that's not going to work for the average John Q. public. What we really need is for this system to be available as a small avionics component, or even potentially as another internal autopilot safety mode. So right now there are things like geofences and return to land modes inside of some of these autopilots. So Safe2Ditch potentially could exist as another safety mode, a safe ditching mode, for example. But we really need it to be its own little widget at the very least, because most of the people who fly these drones, we're not expecting them, nor do we want to require them to be software experts. At NASA, we really don't manufacture these kinds of widgets that are suitable for mass distribution. So we need a commercial partner or a licensee to take the technology and turn it into a product that consumers can actually buy through a website on the mass market. And that's really the goal of our licensing efforts. All of our technology is developed, and our patent is in the form of algorithms, methods, and functionality. We're not actually in a position where we can turn software, none of our flight software, over to a licensing partner. So if there is going to be a successful commercial partner to work with us on this, that would have to be someone who knows how to take these types of algorithms and methods and actually turn them into something that would be compatible for small drone component software as a widget. So that's what we're doing. We're trying to engage licensing partners who will be able to help us with this vision. And from our side of the house, we continue to mature our prototype just to inform the algorithms and to make sure that all of the methods that we envisioned and that we designed are actually working in flight. This picture that you're seeing now on the left side of the screen is kind of an icon that I made up to describe the components that exist within the system in the design and the way it's staged right now in the flight vehicle. So there are different parts of it. The health monitoring interface is actually the point of entry into the system and the part of the system that does the automatic engagement or the autonomous engagement. The health monitor interface basically has an understanding of what the state information should look like if this vehicle were healthy and operating as it needs to complete its mission. And when the health monitoring interface is getting state data from the rest of the system that it can recognize as being out of sync with that, to the degree that it knows it can no longer meet its mission, that's how it triggers the autonomous engagement. When it does that, the intelligent hub, which provides the communication internally between the components and the timing, the intelligent hub then sends the engage to the landing site selection or the ditch site selection component. And this landing site selection is the component in the system that understands through a database of possible ditch site options what the health of the vehicle, so it's getting the potentially disabled vehicle status, so it knows if its range, for example, is going to be impacted. And it uses that information and its known understanding of potential ditch site options to pick the best one for this vehicle under this circumstance. And quite often, and probably most often, that's not going to be the closest one, but it's considering other factors like how reliable is it going to be, empty, how big is this crash site, what's the performance, and how much area does this particular vehicle need to land. All kinds of factors that could influence the choice, including what type of topography is it, and what does the customer want in terms of which sites they would prefer. Maybe they would prefer to have this vehicle actually just ditch into the water or ditch into a place where there's no potential for someone stealing the vehicle. Maybe they have very expensive equipment, and so they have a particular place that they would rather, they think they have a better chance of surviving. So the customer could have some options built in there to prioritize. But in any case, this landing site selection is going to come out with its idea of where the best ditch site selection is. At that point, the nav route optimizer piece is going to be invoked, because this is the component that understands how to speak to the type of hardware that exists for this vehicle. So this system is designed to try and talk to any type of hardware very generally, but the NavRoute optimizer is going to package that landing site selection into a route that speaks the autopilot's language so that it can overwrite the original route and now give it the route to the ditch site. Once it does that, the landing site verifier piece is going to come in and is going to engage and start looking at the site and inspecting for anything that's unexpected there, just in case there's something that has to happen at the end. And as the vehicle closes on that site and the people can be reconciled better, if there is tactical maneuvering that has to happen, it's going to be done by it's going to be recommended by the adaptive controls. The adaptive controls will be able to handle the best reconfiguration of the aircraft for en route optimization if this aircraft's disabled, or it will also be able to handle the tactical maneuvering to respond to unexpected site occupancy. And the intelligent hub, finally, is simply the piece that ties it all together. So it provides all the communication and also the timing to make sure that things happen in the order and at the precision needed. So now if we revisit that notional scenario, our healthy vehicle was en route to a mission, and as long as it stayed healthy, the health monitor component within Safe2Ditch was computing that the vehicle states were adequate for the mission, and so it was not engaging. But when that anomaly occurred, the health monitor then triggered the engagement. It sent the engagement to the intelligent hub. The intelligent hub passed that to the site selection component, which in this picture is called the landing site selection. The landing site selection then started invoking its internal databases for possible ditch sites, applied state information relative to disabled vehicles, and came out with a triaged option that was the best ditch site. Then the NavRoute optimizer piece built the instruction set to get it back to the autopilot to start this vehicle en route to that new site. And then the landing site verification piece switched on. The site was inspected as the vehicle came down to that crash site. And if there was anything in that swampy area, the adaptive controls was ready to recommend tactical maneuvering to complete the mission. So that was from the system, Safe2Ditch system's point of view, that was the set of operations that occurred. I added in some development history so that I could give you an idea of where we are in the development, because we've really been operating on a very small budget. We don't have the whole system completely prototyped by any means. So I wanted to tell you what we do have and what we have done. In 2015, when we started, we were really looking at a feasibility test. Could we even have hobby-grade components that would offer adequate input sources for our signals? And then once we built the system and knew what to do to command it, could we get those back into the system and take control of the vehicle sufficiently to actually get it to the new site? Could a secondary system actually behave as a pilot? Lou and I are both controls people, and we have a lot of experience with the automatics. So the fact that you could, if you had an adequate signal set, that you could build this type of a system was not really one of the risk areas in our mind. The risks were really in getting the signals we needed, doing it in the compute time that we needed, and doing it within the latency of the system that was being used. And so the prototype system was designed and originally flew in November of 2015. At that time, everything checked out and it seemed to go except for one system, and that was we couldn't get an adequate vision system input. We couldn't find a source of the type of motion system, the type of motion in the ditch site based on visual spectrum cameras. And so at the time, that was the one outstanding piece that we saw as adding a pretty high risk. When we came into the second phase of our development, that was our principal thing, was to lower that risk and figure out if we actually could find remote vision feasible for hobby-grade UAVs, so something that could actually fit and be staged on a very small flight computer at the very least for our prototype. And we were able to identify a source for this input, and that was through a group at Brigham Young University. They have a program called RANSAC. The problem with their version of the RANSAC was they had done all the development for larger, very heavy drones like military drones, and so their system was running on a very high-end processor, a very heavy processor. So we invoked the Brigham Young folks who we funded to try and pare down that ransack system to deliver not all the high capability of their original system, but only the bit of that system that we needed to meet the Safe2Ditch requirements. And they actually did that this year. They did it much easier than we expected it to. And we're going to flight test that this summer. They've already done some flight testing of it at their facility out at Brigham Young, and we're going to test that at Langley in a couple of weeks. We also worked on the landing site selection component development. So we have a triaging system now that is probably about 70% of what the final system will have to be to test that out and start getting some data on latency and some of the metrics that we want for the overall system. So both of those are going to be flight tested in early August. The next step, so that's what we've got going on now, and this picture here has got the grayed out areas of the parts of the prototype that we're not done with yet. So everything you see there is what we have, and that's going to be tested in 2 weeks. And then our next thing we're working to is filling out the adaptive controls. So the response, specifically the response to something unexpected in that landing site, and how this system best comes up with a solution of how to tactically maneuver and what works best from the flight testing operations to actually come out with the best safety case. If we're to move on to the next highest priority systems, there'll be the health monitor so it can auto-engage, and then finishing out this landing site selection component. And so that concludes the technical part of the talk, what I was going to give, and I'd like to turn it back over to Sean now.
All right, great. Thank you so much, Trish. Wonderful presentation. So now we're going to move on, and I'd just like to note that one of the primary goals for our Technology Transfer Office is licensing of these NASA inventions, like Safe2Ditch, to industry so that they have the greatest benefit to the public. So before we move on to the Q&A session with Trish and Lou, my colleague Jennifer Viudez is going to give a brief overview on how technology licensing works at NASA Langley. Jennifer?
Thank you, Sean, and thank you, Trish and Lou. Like Sean said, Trish did an excellent job of laying out this particular technology and what it has to offer and the type of work that's ongoing with it. And hopefully you have seen something today that gets you excited, and hopefully I can help explain how to get this technology in your hands. This is a little bit of a brag chart, if you will. The point of this chart is to let you know these are some of our current licensees, and we have licenses with very small businesses, startup businesses, medium size, as well as you'll see Pepsi there. We did execute a license with them this year, and we're very proud of that. And we definitely have examples of local businesses here to the Hampton, Virginia area. So it's just a sample of some of our current licensees. Many of you who are on this webinar today probably found out about it in many various ways, probably emails or marketing technology email blasts that we send out, but we wanted to make sure that you are aware of our technology, gateway.nasa.gov, along with the Safe2Ditch technology that you've heard about today. We have many other technologies that tend to fall in these particular bins of advanced materials, aerospace applications, sensors and detectors, and much more. Here at NASA Langley Research Center, we have about 300 patents that are available for licensing, and I really encourage you to go to this website. It has a robust ability to find your particular search word that you plug in, and if you cannot find what you're looking for, you can still contact us, and we can help you with that as well, because another center might have something that might be of help to your idea and your application. So I'm going to move into the types of licenses just very briefly. I'm sure that many of you on the webinar are familiar with the standard commercial license. Every commercial license here at NASA Langley is definitely negotiated on a case-by-case basis. Folks like me, I'm a licensing specialist here in the Technology Transfer Office. We work very closely and frequently with our potential licensees. We do a lot of negotiating back and forth, so it is definitely not cookie cutter, and all of our licenses are very customizable. I've already shown you a chart of some of the example licensees that we do have. They were probably mostly domestic, but we also enter into international licenses, so that is a definite possibility. So if you're a Canadian company or overseas, you know, do not be discouraged. We definitely have international licensees. And the second bullet, or technically the third bullet, that you see there, the exclusive, partially exclusive, or non-exclusive, these are the types of exclusivity level that you have with a license. So we have licenses where you have the ability for all fields of use, and then we can also create an exclusive license where we can carve out a particular application that might be suitable to you, so that you have exclusivity and can block others out. One type of license that is fairly new, it's probably less than 2 years old, is a startup license. And this is exactly what it says. It's for startup companies. It's very exciting. We have definitely executed several startup licenses, and it allows you as a startup company to keep your money and your cash in your pocket. There are no upfront costs. All licenses under this type of license is non-exclusive. It's only available to U.S. companies, and there are no minimum fees for the first 3 years. So royalties are set at 4.2% for this particular license, and they don't start until the 4th year. So it gives you the chance to have the technology licensed with virtually no cost for the first 3 years. Other than the commercial license and the startup license, we have something called an evaluation license. This is also non-exclusive. It's usually 1 to 2 years, and it gives you a chance to try before you buy. You can take the technology, license it, test it for your needs, and see if it's going to work for you. It's a one-time fee of $2,500. And you can certainly enter into a commercial license at any time during the evaluation license period should you decide before the year is up that this is definitely going to work for you. How to license the technology. I mentioned the technologygateway.nasa.gov. You will find a plethora of information there on that website. You will find our office contact information. You will find the information that I just discussed about the different types of licenses, and you will find an application. This is the first step to licensing a technology, and that is to submit an application. We will need some sort of proof that you are incorporated and you are indeed some sort of company and not just a single person. Financial statement is sometimes, depending on the type of license that you are applying for, that is required. Business, commercial plan, commercialization plan. What do you plan to do with this technology? What is your proposed use? What do you see as the market? The projected revenue and royalty dollars, and your company balance sheet. Now, realizing if you are a startup that you might not have some of these things, and we clearly understand that, and that's why we encourage you to contact our office and to ask questions and to begin that dialogue back and forth based on your needs. Some of the terms that are negotiated, which I've talked about, a lot of this is negotiated, are the upfront fees, the annual minimums, the royalty payment, the field of use being what is your application, what are you going to use it for, and the geographic locations for manufacturing and product sales. So that is in terms of some of the licenses have a requirement to have some of the product, at least some of the product made here in the U.S. But again, I can provide more information about that. This is a review chart of everything that I just talked about. I highly encourage you to contact our office, to send in your questions, things that you think about, questions that you may have for Trish or Lou Glaab, our inventors, our presenters today here in our technology transfer office. So you'll see you have already taken the first step of finding Safe2Ditch. You can contact us, you'll talk to us, determine if this is something that might be helpful for your idea. You can have a chance to set up meetings with Trish and or Lou Glaab to get some further information from them. You may be interested in submitting an application. Our office would review it, and once we determine that you have qualified for it, then we go into the negotiation phase and come to an agreement with the license document and then sign it. And we actually have a physical document that allows companies to use our intellectual property. Hopefully that provides a brief overview of our licensing offerings that we have for you. And again, I want to thank Trish and Lou. We have really terrific inventors here at NASA Langley that we love to brag on, and these two are very special to us, and hope that someone would be interested in licensing this technology. And with that, I'll turn it back to Sean. Thank you.
All right, thank you, Jennifer. All right, like I said before, we set aside some additional time to answer some of the questions from the audience. We've received a lot of them so far. Thank you very much. I'm not sure if we'll have time to get to all of them, but please continue to submit your questions by typing them into the chat box in the GoToMeeting application on your screen. Again, if we don't get to all of your questions today, then we will absolutely follow up with you by email afterwards. So when you register, give us your email. So if you have a question, we've got that all tracked, and we'll make sure that we follow up with you. All right. So Lou, Trish, I'll let you handle how you want to answer these. Also, if you have questions for Jennifer, please submit those as well. But the first question that I have here is, you mentioned that the expected cost of a Safe2Ditch system around $300. At this cost, what do you see being included?
Okay. Lou, do you want me to take it, or do you want to take it?
Why don't you go ahead, Trish?
Okay. At that cost, if it can be brought to market at that cost, it would include basically the software that ties the systems together that would flexibly talk to all the components that are on the system. So it's really going to be a device that is just the set of software algorithms that provides the communication and the autonomous decision making. And so if you have a vehicle that does not have a camera, for example, your Safe2Ditch is not going to be able to do the final inspection of that ditch site. If you have a vehicle that does have, or you're willing to install a siren, then Safe2Ditch is going to be able to tie that in. So for the $300 piece, you're basically going to expect this will be a similar component as might be an autopilot, except its only job is going to be safe ditching of the vehicle. Okay. Next question, Sean.
Yes, and so the next question that I have is, would Safe2Ditch be required for FAA certification?
And I guess I'll just keep talking. Lou, if you want to take over, you can break in.
Yeah, okay. Can you hear me all right?
Yeah, we can hear.
Can you hear me okay? Okay, yeah. So regarding whether or not it would be required for certification, we think that Safe2Ditch would add to the overall safety case of these vehicles and could make the difference between being able to operate in beyond visual line of sight mode or not. So while we don't think it would be written as being required, it could end up being something that makes the safety case work or not. So that's about what we have there.
Yeah, and there are waivers that are granted. So Part 107's got some specific requirements, but if you can make a safety case, then you can get a waiver. And so in the near term, that would be probably the avenue to go. And in the longer term, as these types of systems maybe become more commonplace, maybe it would even get written in some way, shape, or fashion to the next round of regulations for extended site or extended range or something. Okay, next one,
great.
Sean.
Yes. So the next question is the system constantly monitoring for a safe site even when there's no fault or problem with the vehicle?
And the answer is yes, although when it engages, it may not be able to, it's probably going to have to recompute or make another decision anyway. So you're not necessarily going to save time by figuring out in advance, because what may trigger the engagement will be a sudden loss of power or a sudden seizing up of a rotor, for example. And so the previous solution might no longer be within the range of the vehicle. And so as soon as the engagement happens, the system's going to have to identify whether the previous performance capability is consistent or whether the performance is now degraded and it needs to choose a different option. If that doesn't happen, though, it can go with the what was selected last time.
Okay, I'm going to give you two a break for a second because I think we have a question for Jennifer here. If my company licenses this technology, is there a way to work with the inventors to develop it further?
Yes, definitely. And that's one thing that I did not talk about. Outside of a license document that I did talk about, our partnering tool is called a Space Act Agreement. The Space Act Agreement allows NASA to partner with outside entities. And so you may or may not need to enter into a Space Act Agreement depending on Lou and Trish Glaab's available time. We do allow some time for phone conversations, for visits to our center, and if it's something that needs to be more of a longer duration is probably when we would enter into a Space Act Agreement. And if there should be any use of our labs and, again, more of the inventor's time, that's when we sort of enter into a more reimbursable basis. And all of this can be discussed, but we certainly do have mechanisms where the inventors do and can work side by side with the companies to help develop the technology.
Awesome. Thank you, Jennifer. All right, so just a couple more questions today, and again, we'll follow up with you afterwards if we don't get to your question on the actual webinar. So the next question is, does the technology have any features built in to protect a payload in the case of an emergency crash?
You said to protect the payload for an emergency crash, is that? It cut out just a little bit there. Okay, so to protect the payload, and that would be one of those auxiliary systems that we talked about. In fact, we had one a long time ago when we were talking with one customer. They were very concerned about protecting a really high-dollar camera. And you could do that. You could have a separate system that would do something to protect your payload, but it would have to be auxiliary to the software algorithms within Safe2Ditch. And then that would be something that Safe2Ditch would then engage or enable, or if it was a parachute, for example, it would deploy it. And it would be deployed probably under a condition that would say that the vehicle would exceed the tolerance that the customer wanted for how hard it was landing or something like that. So probably I'm guessing the parachute would be the most common type of protection device, but there could be others, and it would be a deployment trigger within the Safe2Ditch system.
Great.
Okay.
Okay, and I think we'll just do one more, and I actually think you touched on this a little bit, so maybe you could just revisit it for a second. But the question is, how many of the components that feed into your algorithm are actually completed?
And the answer is none of, if by completed you mean flight tested, none of them are completed. And truthfully, I don't know if they ever will be completed, because autopilots in general, whatever their intended missions are always in a state of maturity. But for this system, we've always used the limited funding that we had to attack what we saw as the highest risk piece. So we have eaten away at some of that functionality, and we're going to try and finish it out. But right now, we have not prototyped all aspects of the system, just enough of that skeleton so that it's a cohesive system and we could make sure that all the engagement will happen as we need it to. But for example, the health monitoring component right now, it is not taking in signals and comparing it against expected states. It's actually just a time trigger so that the vehicle can autonomously engage. But it's extremely simplistic. It's not what would go into the final system. So hopefully that answers that question.
I hope it did too. Thank you so much, Trish and Lou. Folks in the audience, that's all the time we have for questions today. Again, if we did not get to your question during the Q&A, we're going to follow up with you by email within the next week. We've also recorded this presentation, so we'll be sending out a link to that in case you want to re-watch or share with colleagues. If you have any additional questions, please feel free to submit them to that email address at the bottom there, the LARC DL Technology Gateway. You can also go to our website and find us there to submit questions. Once again, we really appreciate you taking the time to hear about NASA Langley's Safe2Ditch technology. I hope you all have a wonderful afternoon.
Okay, thanks very much. Bye-bye.
Thank you, Sean.